Welcome to our final project for blockchain. We are Group 1 and our project is DocGuard. So, what is DocGuard? Our idea was to create a secure web application to be able to verify document integrity online. Users are able to upload their document to be able to verify them, to be able to sign the document itself, encrypt the document, and also have a timestamp for the document. The documents can be compared with the blockchain itself to be able to protect against tampering. And also with the encryption and the signing, they can then re-upload the document to be able to compare it to see if there's been any kind of tampering, or if they want to decrypt their document.
Thank you, Caleb. Now let's talk about the algorithms used in our application. We're using the SHA-256 hashing algorithm that converts the document into unique hash strings, and then it's added to the blockchain. Once we add the hash to the blockchain, the program gives us a unique document ID, which will show into the application code in a second. This ensures data integrity and that no one else can tamper with the document or deal with the document themselves. For encryption and decryption, we're using the AES algorithm. Why did we choose AES and not a public key is because since our application is limited functionality to blockchain and it doesn't entail key management, so we used AES. So there's like a single key for encryption, both encrypting and decrypting. We're using GCM mode, so the encrypted file is safe for transporting over the network. And the encryption key is only shown once to the user, so it's not exposed to anyone else. For the blockchain data structure, we're maintaining a hashed structure so that we can ensure a tamper-proof record of the documents, and the hashes are stored immutably on the blockchain. And we will show in the code that we have functionalities implemented to confirm that the blockchain is valid and hasn't been tampered with. So let's quickly jump into the code, and I will quickly talk about our algorithms and the structures we have used in this code. So we're using a model view controller structure. In the model, we have the main.py that basically initializes a Flask application, and we're initializing the application here. From the controller, we import the functionalities, which we will discuss in a second, and all of the routes are set in the main.py. So this renders all of the pages that we have and the entire application logic. We also have error handling. So in case if we get a 404 error or server-side 500 error, instead of giving us a bunch of garbage outputs, it actually takes us to a nicely formatted site that shows us the what the error is. Now the control.py is the brains of our entire application. Here you can see that we're importing the necessary modules. We're using AES, we're using a base64 encoding, we're using UUID to generate unique IDs for each document, and we're using PyTZ and time functions for the timestamps so we can verify when the document was added to the blockchain, etc. So this is our blockchain class definition. This is where we initialize the blockchain. And then you can see that we're generating the Genesis block here. This is adding the block. This is getting the latest block. And this functionality basically confirms that the blockchain is valid. So this provides tamper protection. And then this is the function for hashing each document and putting it onto the blockchain. This is the function for uploading documents. We only get the hash and then discard the document. We don't store the document to make sure that the document isn't tampered with or just provides an extra layer of security. Verification is basically verifies that the document hasn't been tampered with. And this is the functionalities for AES encryption and decryption. And this is the functionality for digital signatures. So we can sign the document and verify the document signature again using AES algorithm. Next, we will show a demo of our entire web application. So the application is currently running in localhost port 5000. Let's go to localhost 5000 and we will see our application is running here. So currently, if we click here, this is a human readable format of the current blockchain. So it's not too much information at the same time, and even non-technical people can see this and understand what's going on. If we want to see the detailed or the entire blockchain, we can click here and we can see that this is the Genesis block and this is the hash of the Genesis block. So let's upload a bunch of files to the blockchain and we'll see how the blockchain status updates. This is the upload page. We will choose a test.txt and it gives us a document ID and it tells us that keeps this information secure as this verifies the authenticity of the document. We're going to keep this saved and later we'll see how we can use this to confirm that the document hasn't been tampered with. We will upload a bunch other files just so we have a nice blockchain. We'll upload that and it's been uploaded to the blockchain, and then we will add maybe our project document. Okay, and now if we go to the blockchain, now we can see that we have these files in the blockchain. Now we're not storing the actual file in our servers or the document content to provide security and just to give the clients the reassurance that their data is safe, because we don't even have their data. And if we go to the blockchain detailed status, we can see that all of these hashes and the data is in the blockchain. Now, for the verification, let's go to the text file that we had uploaded earlier. I will open the text file and make some changes to it. So this is the original text file, and it says this is a test file. We're going to add some characters here, save that, and we're going to authenticate if this document has been tampered with. If we go to verification, I will upload the file. Now it's going to ask for a document ID. I have stored this document ID so we can confirm the authenticity with this document ID. We're using the UID module, so each of the document ID are unique. And it tells us that it's been tampered with, but matches the file name on the blockchain. Now, if we revert the edits, and if we save it as it was, and then we try to verify it again using the same document ID, now it tells us the document is valid and matches whatever we have in the blockchain. So since we tampered with the content, the hash has changed, and then it tells us that the document has been tampered with, or if the hash is the same, then we can see that it matches the blockchain record. We can also sign a file, a document, and then the hash of the signed file can be stored on the blockchain. So let's show this very quickly. This is a document we have already on the blockchain, but we have implemented code so it doesn't bug out if it has the document itself and the signature on the blockchain. So it gives us the AES key and it tells us that this code will be basically gone. It will not be displayed again, so we have to store this. This is for security reasons. And if we go to the blockchain, we can see that we have the file and its signature. We appended the signature keyword here so we can distinguish between the actual file and the signature. Now, if we go to verify signature, we can upload the document, put the AES key, and then we can verify the signature. It tells us that document signature has been successfully verified. Now, an additional feature for extra security, we can encrypt a document using our application. Let's encrypt this file here. We will encrypt it, and it tells us that the AES key will not be displayed again, so we should save that. I will put that in the file. And then this is basically the encrypted file, but it's not stored anywhere. We can just get the file as it's being encrypted. It just downloads into our system. And if we want to decrypt the file in decryption, we will put the encrypted file, not the actual file, and we'll give it the key. And it will decrypt, and we can see that it has downloaded the same file and it appended the one because we already had this, and we can see that this is completely legible and the file format has not been changed. We also have error handling in our application. So let's say we encounter a 404 error that the page doesn't exist. Instead of giving us a bunch of jargon, it gives us a very nice formatted page that the page is not found because the resource couldn't be found on the server, and we can just return to home. It also has some error handling for some server-side error handling. So if something like an error 500 happens, it's gonna take us to a nicely formatted page and tell us what the problem was. That was our application. Thanks for watching, and we'll go back to the presentation.
For our conclusion, this is our work distribution. So to start off with myself, at first we weren't too sure what we wanted to do for this project. We didn't really have an idea, and then I proposed the idea of a documentation verification using the blockchain. And with that, we decided that it was a good idea, so we continued on with it. So continuing with that, I worked on the research documentation to answer all the questions and the theory that was needed. I wrote a small portion of the code, which specifically was the tampering verification portion of the code, which included the
Is chain
which
valid?
yeah, which included the is chain valid section, also with the verified documentation section. Along with that, I also am the one that wrote the slides, and I was also doing a lot of testing for the code to see if we could try to break the code or verify some of the errors that we might get.
Other than Caleb's tampering verification part, I wrote the Flask application and the most of the controls for the blockchain structure and all of the functionalities for encryption, decryption, and signatures. And the video that you're currently watching, I was in part of editing that, and I reviewed the research documentation written by Caleb. We also have, just to show us the structure of our workload, we also have everything in our GitHub repository. We have everything documented here. We also have worked on 2 different branches to ensure that we didn't have any conflicts. So Caleb worked on his own branch, and I had my own branch to work off of it. And to make sure that we were working on the features as needed, we had a backlog of features, and then we worked on them one by one. We tested them, and then we marked them as complete. So our current backlog that we wanted to do, but we didn't have enough time to do, that could be a future implementation, could be a user dashboard, so we could implement a wallet, so specific users can see what only they have uploaded to the blockchain, and maybe a homepage graph to show live updates of the blockchain in itself. And these were references that we used in the review of the research documentation. Thank you for watching. This has been Group 1, and we hope you like our application.